Assalamualaikum warahmatullahi wabarakatuh and have a nice day. My name is Nurhanis Alisha binti Muhammad Syaiful, and today I will be showing you how to solve the first question, which is plot the solid that lies between cone z equal to square root x square plus y square, and the plane given is z equal to 4. As we know that spherical to rectangular conversion coordinate is start with rho, theta, and phi. And the formula of this conversion is x equal to rho sine phi cos theta, y equal to rho sine phi sine theta, and z equal to rho cos phi. Okay, based on this formula, we will input the z equal to 4 in that formula, which is z equal to rho cos phi. Okay, and then we will let the phi over there, and then at the end we will get rho equal to 4 over cos pi over 4, and then we will get 4 secant pi over 4. Next, I will show you how to comment this problem. Fx equal to the question given, square root x square plus y square. Okay, after that we will click enter. Will came out as the blue code, and then we will input z equal to 4 because the plane given is z equal to 4. Then we will plot box given. We just need to click the insert and copy this fx from the question given. We'll paste it in the box below. Then it will came out like this. This cone, I declare it as cone. The command is cones colon equal to plot 3D rho theta pi over 4 square bracket, then set rho equal to 0 till 4 secant pi over 4, then theta from range negative pi to pi, and the chords is spherical. I will tell you that the rho meaning is the distance from point to origin, while theta is longitudinal angle. And last one is phi, which is angle that the position vector of the point that makes the positive z-axis. The spherical coordinate is rho, theta, and phi. We replace phi with pi over 4 here because as we know, the spherical cone for phi is pi over 4. After write out the comments, we need to click enter, and our cone will look like this. Okay, next we will plot the next question, which is plane z equal to 4. First thing we need to do is write with open bracket, plots, close bracket, and semicolon, then click enter. The next is we need to I will rename my plane as planes because as I said earlier, it will make me easier to call it later. Okay, the command is plot 3D open bracket square bracket for secant phi theta phi square bracket comma, then set theta from the range negative pi until pi, and phi from 0 to pi over 4. Then the chords is spherical, same with the cones earlier. The command is quite same with the cone before. We just change the rho value to 4 secant phi. If you guys notice, in the cone command, we replace phi with pi over 4 value because we know that spherical cone value for phi is pi over 4. Next step is we need to combine both plane and cone together in one box. The command is plot square bracket display square bracket open bracket square bracket cones comma plane square bracket comma viewpoint equal to circle left close bracket. This is why I tell earlier we need to rename our first task because it will make us easier. We doesn't need to write the long code again in order to call it back. We just need to write the name that we declared earlier. Okay, then click enter. So this is how the combination between cone and plane will look like. That is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Atir bin Zamani and my student number is 2020 476592, and I would like to answer question 2 for lab assignment MAT491. So the question asks to plot the solid that lies above the cone Z equal to z x squared plus y squared and below the sphere x squared plus y squared plus z squared equal to 4. So first, use the restart and with plots command to plot the graph. And next, use the plot 3D to plot the cones graph. So rho theta pi over 4, this is the coordinates for spherical cone, and pi over 4 is the value of p for spherical cone, and the range of rho is equal to 0 to 4 secant pi over 4. We get the value 4 secant pi over 4 from the formula z equal to rho cos p, and we insert the value of z and p, and then we got the value of rho, which is 4 secant pi over 4. So the theta range is equal to negative pi to pi, and because it is spherical cone, so it is spherical coordinates, and we use the chords equal to spherical and axis equal to box, so the graph is inside the box, and then we got the graph is like this. Next, for the sphere, use plot 3D. Based on the question, we get the based on the question here, we get the radius is 4, and the range of theta is equal to 0 to 2 pi, and the range of p is equal to 0 to pi because it is a sphere, not a hemisphere, and it is spherical coordinate, so use chords equal to spherical and axis equal to box, so it is inside the box, and we got it like this. So next, we combine both of the graph and use the plots display. Insert the cones and sphere here, and I use the viewpoint circle left, and the final graph we get it like this. That's all from me. Thank you.
Assalamualaikum. My name is Wanur Akira binti Wal Muhammad Zakiruddin. My student ID is 2020601836. So today I will explain the answer for question 3. The question stated, plot the solid that is inside hemisphere z equal to z35 minus x square minus y square. Outside the cylinder, x square plus y square equal 4 and above the xy plane. So first, we will use restart and with plots command to plot the solid. After that, we will plot hemisphere first. From the equation given for the hemisphere, which is z equal to z25 minus x square minus y square, we obtain that the radius for hemisphere is 5. So, we are using sphere plot command where 5 is the radius, theta is the direction in xy plane, which is 0 until 2 pi, and 5 is equal to 0 until pi over 2. Usually, in a sphere plot, we use 0 until pi. But since we are hemisphere, which is half of the sphere, so we use phi equal to 0 until pi over 2 and axis equal box, which is the solid will be inside the box. So we obtain this hemisphere solid. After that, we will plot the cylinder solid. From the equation given in the question, which is x squared plus y squared equal to 4, we obtain that the radius for the cylinder is 2. So we are using cylinder plot command, where 2 is the radius for the cylinder and the angle is same, which is 0 until 2 pi. And for the cylinder, actually the range for value z, we can take any value. So I will choose the value z more than 0 because the question stated that we need to plot the solid above the xy plane, which is z is more than 0. And then the highest I will choose 5 because I want to compare with the hemisphere solid. So the range for z is 0 until 5 and axis equal to box. So I will get this cylinder solid like this. Next, we will proceed to plot annular plane. Annular plane is basically a ring of circle with a circular hole in the middle. From this annular plane, we can obtain the surface or plane between the hemisphere and cylinder. So, we are using plot 3D to plot the annular plane, where the expression is rho, theta, and pi over 2. Rho is 2 until 5, where 2 is the radius of cylinder and 5 is the radius of hemisphere, and the theta is negative pi until pi, and the coordinates is spherical because of the cylinder and hemisphere in a spherical unit. So we obtain this annular plane where is a difference between radius hemisphere and cylinder, where this is the radius of cylinder and this is the radius for hemisphere. So we can obtain the difference between radius hemisphere and cylinder. After that, we will plot the three solid, which is hemisphere, cylinder, and the annular plane in one box. So we use plot and display command, and we insert the expression hemisphere, cylinder, annular plane, which is from the command that we write, and then viewpoint circle left. And here I already scaling constraint, so this is the output that we get, which is the solid that we want from the question. So here is the annular plane, and inside the hemisphere is the cylinder, and outside the cylinder is hemisphere. So that's all for question 3. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rabiatul Adabiyah binti Muhammad Abdul Aziz with ID student 2020482862. I will explain how I get my answer for question number 4. From question given equation for hemisphere is z equal to square root 60 minus x square minus y square. From this equation, we will get x square plus y square plus z square equal to 16. We will convert this equation to spherical, where rho equal to x square root x square plus y square plus z square. From this, we will get rho equal to square root 16. So rho is equal to 4. So for paraboloid, we know from equation z equal to x square plus y square, we will get rho equal to cos phi cosecant squared phi for spherical. So cos phi cosecant squared phi equal to 4, because from this we will already get rho equal to 4. So from this, we can find the value of 5. This is the coding how to find the value of 5. So for paraboloid, we use this coding, which is this is rho equal to cos phi cosecant squared phi theta phi. Theta we will use a range from negative pi until pi, and for phi we will use the value of phi from this until phi per 2, and we get this shape. For hemisphere, I use this coding, which is this rho equal to 4. Why 4? Because I get that from the hemisphere equation, and range for theta is from negative pi until pi, and for phi I use 0 until the value of 5 we find from this, and this is the shape I get. And last, after we combine it together, we will get the solid bounded for hemisphere and paraboloid. That's all from me. Thank you.